So we are told here that f of a is a function of a Hermitian operator, and this is the property. Okay, fine. And then we need to evaluate this quantity, and the transformation matrix from a basis to b basis is known. And after we are done with this, the b prime is replaced by the momentum operator, momentum eigenstates. Okay, first we'll check a. Okay, fine. So we need to evaluate this. This direct delta will kill one summation, so we'll be left with only one. Okay. These are entries of the transformation matrix. Nothing else actually. Okay, so fine. We have established this. Okay, now we need to move to this. There we will be using the continuous basis. So instead of discrete form, we'll be writing it all there. Okay. Okay, so we can use completeness here. Okay, I think we need another integral as well. So this is r prime is r double prime. So we'll be left with only this one. Okay, so if we use the notation this and p dot h. Okay, so I'm assuming these are all vectors. I'm not going to write this vector notation. It will be less compression. Okay, this is P prime positive and P prime negative. Yes, dot delta. Okay, so this one. You can also reduce this for clearer notation. This is Q dot R. Q. Okay, fine. Okay, and of course, yeah, there is a normalization factor here. These are normalized states. Yes. Okay, fine. What more we can do in this? Okay, yeah, so there will be cube term. So if it is a spherical system, this is z axis, this is r, this is theta, and r cos theta is basically z direction, points in z direction. Okay, so okay, now it is given that r is what you can say a spherically symmetric system. So for that, the volume is actually r square sin theta. D theta d phi. So we can divide this to three portions. This m square dr of r, and there is 0 to 2 pi d5. There is theta is 0 to sin pi sin theta pi over cos theta h bar. Okay, fine. Okay, so just writing as it is. This is 2 pi. And how do we perform this integral? So I just write it as I1. Okay, so I1 is equal to pi d theta sin theta d. We define new variables. Cos theta is u minus sin theta d theta is equals to u when theta is 0. U is 1, and theta is equals to pi is minus 1. Y1 is changed to 1 to minus 1 du instead of sine theta d theta. And this is e power I q r 1 h bar, which gives us, okay, I can just write it downwards. E power I q r u 1 h bar divided by I q r 1 h bar. Limit is from 1 to minus 1. Okay. This gives I q r h bar minus I q r h bar minus I sum. Okay, so there is a negative sign here. Okay, says say I q r h bar. Okay, so this will give us cos will cancel. This will give us minus I sine qr on h bar. This will happen twice. This will give us I squared minus 1. We can write it in like this form just to be more. Okay, so this is our integral. Okay, yeah. So the final integral that we are doing is and I1 was 2. So, okay, so this is 4 pi h bar divided by 8 pi square h bar cube. So infinity pi square sine qr h bar qr. Okay, so this will be 2 pi h bar square So this is okay. So this is what it looks like. We are trying to simplify the expression as much as we could, and this is what it looks like.